Hello everyone. Today we're gonna learn section 3.2 calculus of a vector valued function. So calculus, like calculus 1, we learn about the derivative and then we learn about the integration. So we do derivative about the vector valued function and then we do integrate vector valued function in this section. Okay? All right, so let's do this one. So we have a learning objective and then derivative, we need to use the limit, right? So calculus 1, we did so many limit. After that, we have the formula for derivative, right? So we have differentiation of a vector valued function. So we have, this is a vectored valued function, right? And then this is f of t, I direction, g of t, j direction. This is plane, right? Two-dimensional. And then we do derivative, respectively, right? So f prime of t, g prime of t. If we have a space, then same, when you derivative the vector valued function, we do derivative respectively, right? So f prime of ti, g prime of ti, j, sorry, h prime of tk. Okay, let's do this one. Find the derivative of the first one. Oh, the iPad is slow, so I need to come back. J. Okay, so after that, I'm gonna restart iPad. Okay, so we want to find the derivative of RT. Okay, so we do term by term. So 6t plus 8. So we have a 6i, right? And then j term, we have plus drop the 2. So 8t plus 2j, right? J. Okay, let's do second one. Okay, so second one, we have e to the second, no, e to the second, e to the t power sine t I hat plus e to the t power cosine t j hat minus e to the 2t power k hat, right? So how do we derivative respectively I, j, k? Very good. So we are using product rule. So we have fg. We want to derivative. Then f prime g plus f g prime, right? Okay, so the f of t, the first I term, so we have f, g. So that will be r prime of t. So f prime, which is e to the t power g plus f e to the t, derivative of sine, which is cosine. Yeah, that's the I term. What about second one? No space. Fg. Let me write down here. F prime. We have e to the t. G plus f. 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 G prime. So negative sine t, right? So negative sine t. So let me write down negative here. negative sine t. G. And the last term, so we drop the power. So e to the 2t, then chain rule. So we'll drop the power, right? So negative 2 e to the 2t. So it's minus there. Okay. Yeah. It's okay. Okay, so we have a theorem 3.3 properties of derivative f of t, real valued function, and r of t and u of t vector valued function. So when you derivative, so derivative of c is the constant. So we have a vector valued function. Then it's the same as like treat real valued function, right? So we keep the coefficient, right? Then we do derivative of this function, same as. Okay, we have a sum and difference. So same as calculus 1, we treat like a real valued function, right? So we do derivative this one, the first term, and then we do derivative second term respectively, right? And we have look, this is real number function. And this is a vector valued function, right? So we have these together. Then let's take a look. They say the scalar product. And then look, f prime of t, this is a real number function, just a regular function, right? And this is a vector function. And then f plus, and then f of t, and then vector, 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 uh, vector u prime of t, right? So looks like a product rule, yeah. But then this one is real number. This is just a vector, right? Okay. Now we have a dot product. Let's take a look. Both are a vector function, right? So dot product for the vectors, right? Okay. Then look, the first one prime, we keep the dot product operation. And then second one plus first one, dot product with the second prime, right? So think about the product rule, same as, right? So this one, think like a product rule, and this is also product rule, right? Okay, we have a cross product. Then look, the first one prime, cross product, we keep that. And then second one plus first one cross product with the second one prime, right? So this one acts like a product rule again. Yeah. Okay. 1, 2, 3, 4, 5, 6, 7. Is it 7? 6. 6. So this is a vector. And then we have a real number function inside, right? Then outer first, derivative of outer. And then we keep the inside. And then inside the prime. So this is the same as a chain rule, right? So they have a chain rule. Okay, the last one, they say that dot product itself, it gives us any constant, then dot product with the first one with first prime gives us the 0. Yeah, so let me prove this one. So proof of, is it 7? If, let me just copy. No, we have here. just copy them. One more time. Copy. Yeah. And this is the condition. So let me write down condition. Let dot product with itself is equal to 0. I'm sorry. Equal to constant. Okay. Then we want to derivative. So let's take the derivative. So that will be R over T, dot product of R over T equal to C, right? Okay, so dot product. How do we derivative dot product? So we have number 1, 2, 3, 4 dot product. We get this one. So acts like a product rule, right? With the dot product, right? Okay, then so first one prime with the dot, second one plus first one and second one prime, right? What about the derivative of C? Constant, any constant equal to 0, good. Okay, then dot product is commutative, right? So they are same. So we can say that 2 R over T dot product over this one, right? So 2 R over T dot product of R prime over T, or we can say that R prime over T and R over T, right? So either way, we can say that equal to 0. Okay, now I want to show this one, right? So we do divide by 2 both sides. Then we have R over T dot product with R over T prime equal to 0. All right, let's take a look. So this is the one, right? So if dot product of R over T and itself gives the any constant, then R over T dot product of R over T prime equal to 0, right? So we prove done, right? Thus, let me just copy. Thus, copy. Yeah. Okay, let's do this problem. Okay, so we have this example, and then looks like this is a cross product, right? So let's bring the formula for cross product. This is think about the product rule from the calculus 1, and then we keep the cross product operation, right? So let's take a look. So this is the one, right? So cross product, first one prime, cross product, second one, and plus first one, cross product with the second one prime, right? So note, yeah. Okay, then we want to have this one will be first one prime cross product. Second one, we keep the second one, but the second one has prime already, right? And plus first one and second one prime with the cross product. So u second prime of t, right? Make sense? Can you see that clearly? Okay, so let's do this one. Let's try this one. Yeah. So try u prime of t cross product of u prime of t. All right. But from the previously, from pre, so we have I hat cross product with I hat equal to 0, right? J hat cross product with J hat equal to 0. K hat cross product with K hat equal to 0, right? So we have one vector cross product of itself, then we get the 0, right? So we have u of t cross product of u of t also 0, right? Then we can say that u prime of t cross product of u prime of t, right? That is also 0, right? Make sense? Okay, then this term is, this term is 0. And then we need to look for this one, right? Okay, so what is u second prime, right? So we have to know that. So u prime, let me bring this one. Come on. Oh, there you go. Come on. Copy. So what is u prime? In order to find the u second prime, we have to have u prime, right? So u prime, what do you get? 2t I hat plus j2j hat and plus a 3t squared minus a 3k hat, right? Okay, now second prime, vector notation. So 2i and j0, right? And k plus 6t minus, 0, k, right? Please correct me if I make a mistake. Okay, now we want to do this one, right? U cross product of U second prime. So U cross with U second prime. So I, J, K, U t squared minus 3, 2t plus 4, k t to the third power negative 3t. And then U second prime 2, 0, 60. Yeah. Okay. I hat, J hat, K hat, right? All right. So we have 2t plus 4, t to the third power negative 3t, 0, 6t, j, little bit complicated than earlier. 2j, t to the third power negative 3t, 6t, k, t squared minus 3, 2t plus 4, 2, 0. Yeah, okay. Let's calculate. So, multiply, right? So 6t, 2t plus 4, luckily 0, and minus 6t, t squared minus 3, minus 2, t to the third power, negative 3t, j. And k plus 0 minus 2, 2t plus 4. Yeah. Okay. Okay. So we to distribute, so we have 12t squared plus 24t. I had j, oh my gosh. Let's do j, huh? So j, 6t to the third power, 18t minus 2t to the third power plus 6t. Yeah. Okay, then combining, so 4t to the third power, negative 12t, we do j, right? Sign, let's check the sign, huh? Okay, there is a sign, good. So this is the one, but we have a negative here, right? So that will be negative 4t to the third power plus 12t. Yeah. So negative 4t to the third power plus 12t, j, and k. Let me write down nicely here. 12t to the second power, 24t, I minus plus minus 4t to the third plus 12t, j, and plus negative 4t minus 8k. Yeah, better orange. Yeah. Okay, that's it, right? Okay. Okay, so from calculus 1, what is tangent line? So we had a second line, means that we have 2 points and connect. That is a secant line, right? So that 2 points getting close, close, close each other. Then there's only 1 point, right? So that 1 point we called tangent line. So basically tangent line is touch the graph. The line touch the graph means that there is only 1 point, right? Then we can say that the derivative at the point, let's say that that point is A, derivative at the point is slope of the tangent line, right? Then in calculus 3, this section, we will learn about the tangent vector. So tangent vector means touch the graph. It's a vector, so has a direction. So let me make that so tangent vector. Touches the graph and has direction. Okay, so here's the example. So example of tangent vector. So we have the vector valued function, which is cosine t and sine t. So plane, two-dimensional. And when t equal to pi over 6, so we have r over t, pi over 6 equal to cosine pi over 6 I plus sine pi over 6. So what do you get? Cosine pi over 6, that will be square root of 3 over 2 I hat plus 1 half j hat, right? Okay, that is approximately 0.87 I plus 0.5 j. Okay, tangent vector. So we do derivative at the point. In that case, it's pi over 6, right? So derivative of t, respect to t. So derivative of cosine, which is negative sine t, I had. And derivative of sine t, which is cosine t, right? J had. And then what is the derivative at the point? So negative sine pi over 6 I had plus cosine pi over 6 j hat. Then we had experience earlier. So they will be negative 1 half I had cosine pi over 6 plus square root of 3 over 2 j hat. That's approximately negative 0.5 I hat plus 0.87 j hat, right? Okay. So let me draw. We have unit circle. X, Y. Approximately, okay? So this is a 1, negative 1, 1, negative 1, right? Okay, so R over pi over 6, 0.87, little bit less than 1, right? And then 0.5, so 1, 0.5 here, right? So 0.87, 0.87, 0.9. So how about like this, yeah? So almost a 0.9, right? And then this is a 0.5, right? So that is R over pi over 6. Okay, from there, I want to indicate the R of prime, R prime of pi over 6, right? So that will be negative 0.5 and then 0.87. So negative, yeah, and then 0.87. So this much. So I plot the point here. So what do you think? So that will be, so r prime of pi over 6. Yeah, so I make just approximately from here negative 0.5 I and 0.87 much. Yeah, it's okay. All right, then let me write down the principal unit tangent vector definition. Okay, so we have a principal unit tangent vector. So how did we find unit vector before? So we have a u hat equal to 1 over magnitude of vector v times vector v, right? So we have a vector v over magnitude of vector v is the unit vector. Okay, then we using unit tangent vector. So we are using first letter T here. So vector notation, we know that r prime of T is the tangent vector, right? Then we have r prime of T over, we have a magnitude of r prime will be unit tangent vector. So unit vector that is tangent to the curve. So let's do the example. Find the unit tangent vector of r of t. Okay, so this is the question, but we did this one earlier as it's showing you the tangent vector, right? So we had r prime of t, which is negative sine t I hat plus cosine t j hat, right? Okay, now we need that, right? Copy. So that will be negative sine t I hat plus cosine t j hat, and the magnitude of r prime of t. So that will be square root of negative sine t squared plus cosine t squared, right? So we know that this is 1. So that will be negative sine t I hat plus cosine t j hat. Okay, let's using other question. Let's say that this is A. How about B? So r over t equal to 3t squared plus 2t I hat plus 2 minus 4t to the third power j hat plus 6t plus 5, I think, plus 5. k hat. Okay. So t unit vector, unit tangent vector. So just copy. Better. Copy. Equal to r prime of t, so 6t plus 2 I hat minus 12t squared j hat plus 6 k hat, right? Okay. Or over square root 6t plus 2 squared plus negative 12t squared plus 6 squared, right? Okay. Note square. So let's do this one. Yeah. 6t squared plus 2 times 6t plus times 2. That's 144 t to the fourth power plus 36. Yeah. So that will be 36t squared plus 24t plus, oh, missing 2 squared, yeah? Missing 2 squared. So it's 4. Okay, combining like terms, so we have 144t to the fourth power. That's it? Huh? And 36t squared plus 24t and then 40. Yeah. Okay. What else we can do? Look. I want to factor out with the 2. Okay, equal to 2 out. So 30, not 30, 3t plus 1 I minus 6t squared j plus 3k over 2 square root. Then supposed to be 4 out then, right? Okay. So that will be 36t to the fourth power and 4 out. So 9t squared. So 4 out. So plus 6t, 4 out is 10, huh? So that will be 2, right? So then simplify. So that is the answer. Plus 1 I hat minus 6t squared j hat plus 3k hat over square root 36t to the fourth power 9t squared plus 6t plus 10. Okay, so derivative, right? Let's do integration. So definite integral. So it's the same as like a real valued function. So we have definite integration. So means that there is a limit or lower bound, upper bound, right? And then we do integrate respectively, right? So first term and then second term and third term. Yeah. Okay, let's calculate. So this one is indefinite integration. So we have a 3t squared plus 2t. I have plus a 3t minus 6j term plus 6t to the third power 5t squared minus 4k term. And then derivative, ooh, integrate respect to t, right? Okay, so we split 3t squared plus 2t. Oh, dt, huh? dt, I have weird notation, huh? So let me double check. So dt first, then I, yeah. So they use a notation like that. Okay. Now, plus integral 3t minus 6 dt j and plus integral 6t cubed plus 5t squared minus 4 dt k. Sorry, no space. Oh, okay, never mind. All right, so let's do integrate. Okay, we think reverse from the derivative. So we add the power, divide by the new power, right? So t to the third power plus we add the power, divide by new power, so t square. This for I, yeah. Okay, we add 1, the power, divide by new power, so t to the second power, 3 over 2, t to the second power, minus 60, j. We add 1, so t to the fourth power, 6 over 4, plus t to the third power, 5 over 3, minus 4t. Yeah, and then k. We need to simplify this one, right? Can you simplify this one? 6 over 4, 3 over 2, right? 3 over 2. Yeah. I don't want to carry one more step. And then this is the indefinite integration, so we should add plus c. Yeah. Okay, so let's try this one. This is the first. Second. So we have from 0 to pi over 3 sine 2t and I hat plus time t j hat plus e to the negative 2t k hat dt. All right, so we want to integrate sine 2t. So note sine 2t dt. Yeah. Okay, use substitution if you cannot think quickly, right? So let u equal to, which one? Is it sine or is it 2t? It's a 2t. Then du, which is 2 dt. And then we want to replace the dt, so divide by 2 both sides. So we have 1 over 2 du equal to dt, right? So that will be sine mu dt will be 1 over 2 du. So we have a 1 over 2. What's the integral of sine u? So cosine u, we have a negative, right? And plus c, indefinite integration in the case, yeah? So then what's the u? Negative 1 over 2 cosine 2t plus c, right? Okay, let's do it. Tangent. Oh, we have to have a tangent too. Oh. Okay. This is from textbook. Yeah, I did not make it. So let's do tangent. Note. We have tangent t. Okay, tangent we can express as sine over cosine, right? So sine over cosine. Okay, so if you cannot think, basically there is a least method. So when I taught the calculus 2, so you can think easily if you are using least method. Yeah, please watch it, my video, least method. Okay, so tangent t equal to sine t over cosine t. So if you cannot think, use substitution, right? So let u equal to which one? Sine t or cosine t? Cosine t, good. So cosine t, and derivative of cosine t is negative sine t dt. Okay, so we have a sine t dt, but we don't have a negative, so we divide by negative 1 both sides. So we will have negative du equal to sine t dt. So sine t dt will be replaced by negative 1 du, right? So negative, put the negative sign outside of integral notation. So we will get negative du over u. What do you get? This one. We've seen this one a lot, right? So there will be negative, good job, natural log of u plus c. So u was cosine t, so cosine t plus c, yeah? Okay. We know this one? Or you want me to do that? Okay, so since we do that, and we haven't done the integration long time, so let's do that too. So e to the negative 2t, e to the negative 2t. So once again, if you cannot think quickly, we using new substitution, let u equal to what? Is it e or is it negative 2 or negative 2t? Negative 2t. Derivative negative 2 dt. Okay, so we don't have a negative 2, so divide by negative 2 both sides. So negative 1 over 2. Oh, negative 1 over 2 du equal to dt. So that will be negative 1 half e to the u du equal to negative 1 half e to the u plus c. Negative 1 half. What's the u? Negative 2t plus c. Yeah? Okay, so all together, let's do it. So we have, let's do that one more time. Okay, so that would be sine 2t, we had negative 1 half cosine 2t, and definite integration, right? And we have to have I, So 0 to pi over 3, and then I hat. Little bit weird the notation. And tangent t, we have negative ln cosine t, indefinite integration, right? And j hat. And 0 to pi over 3, j hat. And the last term, we have this negative 1 half e to the negative 2t. And then 0 to pi over 3, k hat, right? Okay, let's do it. All right, so negative 1 half cosine 2 pi over 3 and minus cosine 2 times 0 I had minus ln cosine pi over 3. Oh, come on. Cosine pi over 3. Uh, it's a natural log. Um, the sign. Let's think about the sign. minus. So we'll get the minus minus positive, right? Right? So it's a positive. Natural cosine 0 and j hat. Okay, the last one minus again. So hold on 1 second. Let's think about the first one. Okay, we have negative. So we factor out the negative. Negative, negative is positive, right? It's okay, right? And third one, minus 1/2 e to the negative 2 pi over 3 minus e to the negative 2, 0. K hat, right? Okay, so let's calculate pi over 3, 2 pi over 3, right? Cosine 2 pi over 3, we get negative 1/2. Negative 1/2 cosine 0 is 1. Yeah, I had minus cosine pi over 3, which is a natural log of 1/2 plus cosine 0 is 1, right? So ln 1 j, and the last term minus 1/2 and e to the negative 2 pi over 3 minus e to the 0 power k. Okay, so let's calculate. So this is 2 over 2, so negative 3 over 2. So negative 3 over 2 over, I'm sorry, negative 3 over 2, and the negative is a positive 3 over 4. Yeah. 3 over 4, I had ln 1 is 0. So we have a negative ln natural log 1/2 j term and ln 0 is 1. So we get plus negative negative 1/2 e to the negative 2 pi over 3 minus 1 k hat. Yeah. So that is the final answer. Okay. Any questions? Thank you for watching. I will see you in the next section. Thank you so much. Bye.